Humanity just punched an asteroid. On purpose. And get this, the asteroid punched back with a cloud of boulders so big it tripled the shove we gave it. That single collision didn't just prove we can steer a space rock. It launched planetary defense into a brand new era. One where the rocks fight dirty and our playbook is being rewritten on the fly. Stick around because the wild plot twist scientists saw in the debris is already shaping the next generation of asteroid deflecting tech, and some of it sounds like it's straight out of science fiction. Why we needed to throw a punch. We've all seen the movies, right? A city-killer asteroid looms, Bruce Willis suits up, credits roll. Real life is quieter, slower, but the stakes? Absolutely everything. Back in 2013, the Chelyabinsk meteor injured 1,500 people and blew out windows across 6 cities, though it never touched the ground. That rock was barely 20 meters across, smaller than a Walmart. Now, picture a kilometer-wide mountain arriving at 30 kilometers per second. Civilization isn't just shaken. It's game over for harvest, supply chains, maybe even democracy itself. Here's the kicker, we can't stop what we can't see and we can't see everything. Roughly 30% of the 25,000 near-Earth asteroids big enough to flatten a country remain undiscovered. Many travel in binary pairs, 2 rocks dancing around each other like a cosmic waltz. Hit one and you might just swap its dance partner into a more dangerous path. So, before we gamble the planet on a Hollywood bomb, we needed a test fight in an empty ring. That ring was 11 million kilometers away, circling a 160-meter moonlet named Dimorphos, just minding its own business around its bigger sibling, Didymos. Cue DART, the Double Asteroid Redirection Test. The mission that worked too well. Picture a vending machine-sized box with roll-out solar wings, a xenon ion thruster the size of a fire extinguisher, and one job: ram into Dimorphos at 6.6 kilometers per second. Launched in November 2021, DART spent 10 months lining up that shot, snapping selfies and streaming starfields like a cosmic tourist. On September 26, 2022, it went dark, right after the Italian CubeSat LSA Cube snapped the money shot, a white-hot plume exploding into space. Within days, telescopes on Earth measured the moonlet's orbit, which was nearly 12 hours long, shrinking by 32 minutes. NASA's goal had been 73 seconds. We overshot by more than 25 times. Mission managers popped champagne, then looked at the images again, and their jaws hit the floor. The plume wasn't just dust, it was a swarm of house-sized boulders. And they weren't just drifting. The recoil from that blast of debris rocketed Dimorphos with more force than DART's own punch. Think of it like this: DART's impact was a punch, but the spray of rock it kicked up acted like a jet engine, giving the asteroid a huge secondary push. We learned the asteroid was less a solid rock than a floating ball pit. That single insight is why every future deflection plan is now being redrawn. Space rocks are weird, and that's a problem. For decades, scientists modeled asteroids as solid lumps. Plot twist: half the ones we visited are rubble piles, gravity barely holding together cracked rock, dust, and empty space. Hit a rubble pile and you don't carve a crater, you squeeze a stress ball. Material squirts sideways, clumps back together, or spins up like a fidget spinner. That spin can lower the asteroid's effective gravity so much that boulders just wander off into space. Either way, predicting the push you get is no longer simple. It's like trying to play pool, but one ball is made of solid resin and the other is a bag of sand. All our math was for the solid ball. DART showed us we have to learn how to play with the sandy one. Miss the calculation and you could turn one bullet into a shotgun blast still headed for Earth. Meet the next contenders. So, if simply hitting an asteroid gives us unpredictable results, what else is on the menu? Option A, gravity tractor. Imagine parking a heavy spacecraft beside a threatening rock and letting its tiny gravitational pull act like a cosmic tow rope. Over 10 to 15 years, a 1-ton probe's gentle tug can shift an asteroid's track by thousands of kilometers. No debris, no drama. The downside: you need decades of warning, lots of fuel, and a very reliable spacecraft. Option B, laser ablation. Think of this as giving the asteroid a slow-motion rocket engine. By focusing powerful lasers on the surface, you vaporize rock into gas. That escaping gas acts like a gentle, continuous thruster, pushing the asteroid bit by bit. No violent collision, just photons and patience. NASA's D-Starlight concept claims a 100-meter asteroid could be nudged in a year with today's power tech. Bonus: you can steer or stop by flipping a switch. Option C, ion beam shepherd. This is like using a cosmic sandblaster. A spacecraft fires a high-speed stream of atoms like xenon, plastering the rock for months or years. Each atomic impact is tiny, but together they create a persistent, ultra-precise push. The beauty is you can tune the beam and back off if the asteroid starts misbehaving, giving you incredible control. Option D, nuclear standoff. Think of this not as a direct hit, but like setting off a powerful firecracker right next to a pile of sand. Detonate a nuclear device nearby, and the flash of X-rays instantly vaporizes the asteroid's surface layer. That vaporized rock blasting away from the surface provides a massive shove. Treaties currently ban nukes in space, but for a giant rock spotted with little time to spare, this remains the only option powerful enough. DART's rubble pile surprise, however, adds a complication. We'd need to know if the shockwave would safely push the whole pile or just break off chunks that could still hit us. The Hera Forensics Team. After a successful launch on October 7, 2024, ESA's Hera spacecraft is now on its way. Arriving in 2026, it will act as a forensics team at the scene of the DART collision. Think of it as CSI, Space Rubble. Hera will scan Dimorphos with lasers and radar, mapping every boulder and the crater DART left behind with incredible precision. Its data will be plugged into computer models that decide whether a future threat needs a whack, a tug, a gentle cook, or a bigger blast. The mission is also testing autonomous navigation, tech we'll need if a last-minute intercept has to fly itself because Earth is blocking the radio signal. If DART was the punch, Hera is the slow-motion replay that teaches us how to swing better next time. If you're into real science that reads like a thriller, hit subscribe and ring the bell, because over the next few months, we'll be tracking Hera's journey and breaking down every new planetary defense experiment the moment data drops. Countdown to Apophis. On Friday, April 13, 2029, the 340-meter asteroid Apophis will dip below our geostationary satellites, so close it will be visible to the naked eye over parts of Europe, Africa, and Asia. It won't hit, but Earth's gravity will squeeze and stretch it, possibly triggering tiny landslides on its surface. Those landslides are a free physics experiment. Watching how the spin changes and how much surface material shifts will help calibrate deflection models without firing a shot. NASA and ESA are already planning to send scout probes to tag along for the ride. So mark your calendars. The next big rehearsal for saving the world might be a spectator sport. What the new path looks like. DART proved we can move a cosmic target. The Boulder storm proved nature doesn't play fair. Put together, the new playbook looks like this. 1. Find everything first. We need to finish the space-based NEO Surveyor telescope to spot threats decades out. 2. Characterize fast. Send a lightweight scout to any concerning rock. Know if it's solid, a rubble pile, or a sack of marbles before you act. 3. Pick the tool, not just the hammer. Kinetic impactors for solid bodies, gravity tractors or lasers for rubble piles, and nukes for the true planet killer we spot late. 4. Practice diplomacy. Any real deflection will be a multinational call. The math is global, the fallout is global, and the politics must be global. 5. Keep iterating. Each mission feeds a growing library of asteroid personalities. The more we learn, the smaller the margins we need to guard. Conclusion. We started with a single probe, a single asteroid, and one bold idea. Maybe we don't have to sit here and take it. DART landed that punch, then handed us homework we never saw coming. The reward? A species that no longer faces extinction with folded arms. Next time you look up at a shooting star, remember, somewhere a spacecraft is quietly rehearsing the day we might have to shoot back. If this story fired your curiosity, share the video, drop your favorite deflection idea in the comments, and check out the playlist on the channel for the full inside scoop on Hera and beyond. Subscribe, stay curious, and keep watching the skies, because the universe definitely has more curveballs on the way.